With your Unity Hub open, you'll see all the projects that you have available. Now click on New Project and then make sure that you are on the editor version 2022.3 at least. Type in a project name and make sure that you select 2D Core, because what we're going to create today is a 2D game. It's not going to be 3 dimensions. And then choose a location where you want to save this. I use a folder that I created, and you can use any one that you would like. And then click on the Create Project button. Now Unity will open up a new project. It takes a few seconds. And here we have it. The Unity dashboard, where you can start creating your own experiences, and this has to be one of the most powerful pieces of software ever created by mankind. Unity is available for free as long as your project that you are working on doesn't generate more than $100,000 per annum. So I think for our games that we are going to make, we'll be perfectly fine. We won't be making that large amount of money, or hopefully we will, but alas. So just a quick overview of how this piece of software works. First off, here in the right hand corner, what I would like you to do is make sure that it's on 2x3. So this is the layout, and there's different formats that you can lay out your Unity platform, your Unity software, and I prefer to use the 2x3 setting, because then you've got access to everything that you need to access. So it's split into a few different windows. First, we've got the scene window, and this is where we'll be doing most of our work. So this window over here is where we'll be setting up Unity, our game. It's how we're going to interact with all the objects that we bring into our game, and this is going to go into our scene window. Yeah, at the bottom we've got our game window, and this is how our game will look. So everything that we place here will be present here as well, but the game window is exactly how the end user will see our game. We've got a hierarchy. The hierarchy is going to list everything that we have. For instance, in our scene, we currently have a camera. Now this is the camera that captures everything and sends it to the game to the game window. So this is a very important aspect, is to have your camera up ready. Then we've also got a project tab with all the available folders, and this is how we manage all our assets. And you can drag these windows to a size that suits you well on your screen. So we've got a project tab, and then we've got an inspector tab. Now this inspector tab, that's where we make minor adjustments and tell Unity how exactly our game objects that we insert into our game is going to behave. So that, in a nutshell, is how the Unity platform looks. We can maximize it. And then we've got 3 buttons here at the top. The first one is a play button. If you hit that, that is going to start your game. So whatever you do, if you want to test it, you can just press the play button and then it'll start your game. Our current scene is called Sample Scene, and that's not a very good name for it. So let's start off by saving it as something else. Let's call it our game, and we'll save it in our scenes file, in our scenes folder. So keeping track of all your assets is one of the most important things in game development. and it's something that I struggle with personally, because I'm very lazy when it comes to housekeeping. But keeping good track of all your resources in these folders will make your life a whole lot easier. So we've got our scene named as game now. And first and foremost, what we should start off with probably is going to be our rocket ship. Now, in the folder that I've shared with you, there is a couple of files that we'll need to import into Unity. So in the folder that I shared with you, you'll see there's a folder called sprites, and sprites are just a very fancy way of saying that these are going to be our game objects in a 2D gaming environment. So these are going to be what we'll program, what's going to become our game objects, and what we'll use to entice our players to enjoy the game. So you'll see there's a rocket, there's a few different fires that we'll be using. But now we need to get this into Unity. So let's start by making a folder, right-clicking, create folder, and we can rename that folder. So if you didn't get that, it's right-click, create, and then select folder. And if you just click once on the folder name, you can rename it, and we rename it to sprites. Now double click on the sprites folder so that we are in that sprites folder. Drag all the different PNG files into that sprite folder. So that imports it into Unity, and now we can start to use all these different files. Now if you click on one of the files, you can see all the settings that you can change on each one of these. For now, we'll just keep it like as is. There's no need for it to be changed for our game, so we'll just keep it like this. Now that we've imported our sprites, we can start to build our game. So let's start by taking the rocket, dragging it over into our hierarchy, and you'll see a massive rocket appears in our game. So this is way too big. We need to make it smaller, and we can do that by going to our inspector. So on the inspector we get a lot of different values that we can change. We can change the position. If we change the X position, it changes it on the X axis. If we change it on the Y, it changes on the Y axis. Let's just return those to 0, so you can type in a rotation. You can type in a position. You can also rotate your sprites into any direction that you would like. But for now, we want to make our sprite a little bit smaller. So let's try 0.05 and see how that looks. So that kind of looks good. We've got a smaller sprite. It seems to fit in our screen quite well. But for our screen, we need to change things up a bit. So on the game panel, what we'll need to do is change from free aspect to full HD. We are developing this game for PC, and PC screens are normally full HD, so it's going to be 1920 pixels by 1080 pixels. That is the standard full HD screen that we're looking for. And now we've got a rocket in our game already set to go. But there's a few other things that's bothering me. We've got a blue background. Now this blue background is from our camera. Our camera is giving us this blue background. So if you click on the camera and you click on that background color, we can change this to any color that you'd like. And I think since this game is going to be in space, We can make it a nice deep dark black. So we've got a black color, we've got our rocket in the scene, and we are ready to take a look at how we can make our rocket fly. So since we have our rocket, let's move it up a bit. So over here you've got different tools that you can use, and if we want to move it, we just select the move tool, and then you can move it on the axes that you'd like. So let's keep it on just about there. And now we want to set up fires for our rocket, so all our thrusters. By double clicking on the rocket, we zoom in to see it a little bit better. Now we've got different fires that we can play around with, and the first one that we'll be using is going to be the fire. Now if we drag and drop the fire into our hierarchy, you'll see that again it's going to be a very massive fire. And the problem is, if you move your rocket in any direction, the fire will just remain. And that's not what we want. We want our fire to move with our rocket. Now, this is where the terms of parents and children come in on the hierarchy of Unity. So if you were to take the fire and drag it and just onto the rocket, you'll see that it shifts a little bit to the right. And now this is parented or childed to the rocket. So whenever the rocket moves, so too will the fire move. But again, our fire is very, very big. So let's make that a little bit smaller, and let's place our fire in the position where it should be. So that looks about good. Let's zoom in, take a nice look, see that our fire is pixel perfect. So what you'll see is on this side we've got some fire leaking out on the side, which is not on that side. It may be a little bit pedantic, but trust me, gamers can be very, very nitty-gritty when it comes to visuals. So let's just move our fire up until we find a spot where it fits in quite nicely. Yeah, I think that's quite close enough. So we've got a fire behind our rocket. Now rockets needs to steer in other ways as well. So what we should have is a little bit of thrusters. This is going to give us forward momentum, but we need to have different fires for getting us to the sides. So let's add our thruster, and again we're going to parent child it to the rocket. We're going to make this smaller. So there we've got our thruster, and our thrusters are going to be placed on our wings. So we'll have one over there, and then we need one on the other side. Now, quick trick, if you want to copy anything in Unity, you can simply use Control D. Control D makes a copy of anything that you've got selected. So I've selected the thruster, hit Control D, and then I'll just move it there to the back. Now we've got thrusters on both sides. Let's see if it looks good. I think it looks quite symmetrical. So let's hope the gamers are happy with what we did here. So we've got thrusters, and what do we need more? Well, we need to perhaps have forward thrusters to go back. So let's add these backwards thrusters. We drag it onto the rocket. Again, we make it smaller so that it fits. Position it at 0, and then we drag it so that we have our thrusters where we'd like it. And then we've got loads of fire coming out of our little game rocket. So it's beginning to shape up quite nicely. But if we hit play, it's going to load our game. And absolutely nothing is going to happen because we haven't programmed anything yet to start to happen. So let's exit play. And this is something very important because anything you do whilst you're in play mode doesn't get saved. So if you do a lot of work whilst you're in play mode and you accidentally didn't go out of play mode, nothing will be saved. So make sure that you're not in play mode whilst you're working. Okay, but before we can start programming this, let's just do a little bit of our tidying up. So we've got a rocket, we've got a thruster and another thruster, but let's label these a little bit better. You can click on it twice and then we'll say this is our left thruster. And if you don't want to change the name here, you can also change it here in the inspector whilst it's selected. This is going to be our right thruster. Got our fire at the back and we've got our backward thruster. Now we know what is where and where is what. So to make our rocket move, we need to add a few things for it to be able to move. And the first thing that we need to add is a script. Now, Unity uses the C# coding language, and it's one of the easiest coding languages, in my opinion, to learn, while still being very powerful. So click on your rocket, and then here in the inspector, click on Add Component. Now, what we need to do is we need to add a script that's going to manage our rocket. So let's call it Rocket Controller. So you type that in, and then you'll see that there's a new script option. You select that, and you select Create and Add. And that generates a script that we can edit in Visual Studio. Now, Visual Studio comes along with Unity for free, and it's quite interesting how much artificial intelligence has been enabled in Visual Studio to make your life a whole lot easier. So right click on Rocket Controller, our script, and say Edit Script. And that's going to open up the Visual Studio Visual Studio software. So let me just drag it over so that you can see. And this is how our script looks. So here we'll be programming, we'll be saying exactly what needs to happen with our controller for our rocket. And what we need to do is we need to make our rocket go left and right. I think that's quite a needed aspect to it. Now, in coding, there's a few different terms that get used, and as we go through this process, I'll try my best to elaborate a bit on it. Now, we need to declare a variable. This variable is going to tell the rocket how much it should be moving. And this is going to be a float. So a float is just a fancy descriptor for a decimal number. So we've got a float, and we're going to call this float move horizontal, because it's going to tell our rocket how much it should move horizontally, and it's going to be a float. So it's going to be a decimal value. So then we need to tell it an equal sign, and we are going to use Unity input system. So all you need to type is input with a capital I, get axis, and then we want the horizontal axis. Now that tells Excel, that tells Unity what the float is going to be that it needs to change, but it doesn't tell it that it needs to change. So we need to have another line, and this is going to be our the exact amount that it needs to change. So this is going to be a vector 2, meaning that we've got an x and a y, and we want this to be this vector 2 is going to be called our movement horizontal, which is going to be a new vector 2. Oh, vector 2, not 22. Move horizontal, that is the variable that we created now. And you'll see that Visual Studio predicts what we want. So we want our new vector 2, and it's going to be a 0 on the y-axis. So we wanted our new variable to move horizontally, but not on the y-axis. And we end off each statement in C# with a semicolon. So please remember that. So that's going to tell it how to move horizontally. But what about vertically? We want to go forwards and backwards as well. So we just copy our code there, and we change this over to vertical. So all the horizontals change to vertical. Now here we need to remember that we're dealing with the vertical, so up and down, and then it's going to be on the y-axis, not on the x-axis. So it's going to be move vertical on the y, and the amount of vertical movement on the x-axis is always going to be 0. So I know this might look like Chinese for some of you, unless you understand Chinese, but as you go through coding, and as you struggle with the terminology, and as you go onto Stack Exchange and YouTube, that's how you're going to learn. It's a intensive process that takes some time. For now, you can just copy the code exactly as it is, and try and figure out how it works. But ultimately, it's like learning any new language. It does take some time. So now we've gotten our exact values that we know that it needs to change, but we haven't set up exactly how this is going to change for Unity. So we need to program that in now. And for us to be able to program this in, we need to add something to our rocket in Unity. So let's go back to Unity. And whilst we've got our rocket selected, we need to add a rigid body. Now, a rigid body just tells Unity that this is something that is a object that needs to be simulated. And here you can see what you can simulate. There's mass, you can give it angular drag, linear drag, you can have different gravity scales, so a lot of different aspects that you can change. Make sure that you choose the rigid body 2D, because we are busy with 2D programming in Unity. It does make a big difference if it's a 2D and a 3D object. Well, now that we have our rigid body attached, we can reference that rigid body. Meaning we can tell Unity, or the code at least, to go and look for that specific rigid body that we want to have moved here. So to do that, we need to go to above start and below this curly bracket. And here is where we can define different variables that's going to be used throughout our script. Now what we want to say is we want this to be a private object. So what private means is that outside of this particular script called Rocket Controller, nothing will ever be able to see this variable that we created. So it's a private variable. It's only in this particular in this particular script. So we want a private, and it's going to be a rigid body. So now we tell Unity what this variable is going to be. So it's a private rigid body 2D, and again this coincides exactly with what is in Unity. So if you look rigid body 2D, that is what we want to try and access. Now remember, this script that we are working on, Rocket Controller, is added to the rocket, and this rigid body is also added to the rocket. So they are both on the same object in Unity. That is important because once we reference it, there is a difference if it's on the object or if it's on another object. So we want a private rigid body 2D, and we're just going to call it RB. So lazy typing, we're just going to type RB. Now this is a private variable, meaning it's only in this script. We cannot access it from outside. But now we need to tell it what is this RB. So in your start section, you're going to type in RB, referring to that rigid body, and we want to search for this rigid body. So we're going to do that by saying equals getComponent. Now we're using getComponent here because it's attached to the same object that its script is. So whenever it's on the same script, you can just use getComponent and then open these larger and smaller as signs, and then type in, we are looking for the rigid body 2D. Now this is one of those very strange things that looks very strange when you start off, and then it becomes second nature, because you now need to have parentheses and a semicolon. So grammatically it doesn't make any sense at all, but in C#, this tells us C# and Unity to just go and look for the rigid body and take everything from the rigid body and add that to our variable that we called RB. Okay, so now we've got RB, which is great. And something that I neglected to tell you is that we've got these two different methods. So we've got start, and start runs way at the beginning of the program. So it runs once and only for one frame, and it runs through the software, and then it goes into update. So update is for every single frame of your game. Update is going to run. So for every frame, we're going to do these calculations. That's the difference between start and update. So you've got start, you've got update, and we've now gotten our rigid body. So this script knows what rigid body we are looking for. Now we can start working with that rigid body. So what we need to do is we need to tell that rigid body how it's going to move now. Now we will simply say that RB, our velocity thereof. So if whenever you have a variable, you can select specific subcategories and sub-information of that variable by typing a full stop. And you can have a look through all these different aspects that you can modify in the script here, but we are interested in the velocity. So we are going to change the velocity of this rigid body, and we want this to be our movement horizontal. Horizontal. Shucks, my horizontal. My typing has gone out. We wanted the movement horizontal, but we also want our movement vertical. And we'll just place these into brackets into so that it knows that is a sum that it needs to do. And now if we go back into Unity, well, first off, save, Control S, or click on save. So if we head on back to Unity and we press play, we'll see, oh no, all compiler errors have to be fixed. So let's go back. That means we missed something in our script. And here is our error. So there's a red line, squiggly line over there, and it tells us over here that there's a major error. It needs a semicolon. So we type in our semicolon, again save. If you don't save, it's not going to clear up that error. And let's go and test our script now. So here is our script, and if I type the WASD keys, we see a little bit of movement, but it's very slow. So I wonder why. Let's play around here, and we make our gravity 0. Click on play again. It is very, very slow. Now, how can we overcome this very slow speed of our rocket? Well, we can just add a little bit of speed to it. So if we go back to our script, let's declare a variable here beneath our rigid body. So we are going to call this public, because we want to access the speed outside of our script. So we're going to make this a public variable, and I think for the purposes of our game, we can make this an integer. So a public int. Now this means it's going to be a whole number, so a 1, a 2, a 3, not a 1.5 or anything along those lines. And we're going to call this speed. So we've got that, we've got our semicolon, which is very important. And to get our speed active, what we can do is we can multiply that by our speed. Let's save it, go back to Unity, and now if we go to Rocket and we look at our Rocket controller, we see that there is speed. Now if we were to hit play and try and do anything now, nothing will happen because our speed is currently at 0, meaning that it's going to do nothing for our game. So basically it's just gravity pulling this back. Now let's increase our speed to 5 and take a look then. There we go. Now we've got a rocket that can move. Let's increase our speed to 10. our rocket is moving faster. So you can play around with the parameters, and you can decide on what you want your rocket to be able to do. I would say that 100 might be a little bit too fast for most gamers, but alas, let's see what you come up with. So we have our rocket, and if we enter into play mode, we can move our rocket around, but if we don't do anything, we see that it moves backwards. Now this is due to the fact that we didn't tell Unity that this rocket is actually in space where there's zero gravity. So what we need to do is we need to tell Unity. So stop the play so that it remembers what we're doing. And here under the select the rocket, under rigid body, gravity scale, make that 0. And now your rocket will not move backwards any more. So if you keep it there, it will be there for it's very static whilst you're not pressing any buttons. Now we've got these thrusters, but they're not supposed to be lit up all the time. For instance, these backward thrusters only needs to be activated if we actually want to go backwards. So we need to tell Unity to switch these on and off for us. And we can do that in the script again. So let's go back to our rocket controller, and again in the update what we want to do is we want to activate certain thrusters only when we press certain buttons. So to do that, what we'll do is we are going to use an if statement. Now an if statement is exactly what it says. If something is happening, then what should happen? Now this is one of the most important pieces of coding that anyone can ever do. Bill Gates said that if you know how to do an if, you can write a second Windows. I'm paraphrasing a little bit, but that is how important an if statement is. So we are going to use an if, and what we want this if to do is to switch on and off certain thrusters. Now let's start off with our fire that's at the back. I think that's going to be our first use, and that's only going to be activated if we want to go forward. Now if we want to go forward, we use the W key. So if, and the code that we're going to use now is input. So we want to get our input, and then we can use get key. So get key looks for a specific key. We open our brackets, and then what the key code that we are looking for is going to be W. So if our input get key gets a key that's W, what should it do? Now we open up curly brackets. These curly brackets tells C# that everything on this level is associated with this if. So anything that's written in here is only going to happen if you have this if activated. Now what is it that we want to do? Well, we want to create fire. So we need an instance of that fire over here. So what we're going to do is we're going to say public, because we want to access this from Unity and make it easier for us. So we're going to say public, and we want to create a game object, or access to a game object. Remember that fire is in our hierarchy, so that makes it a game object. And we're going to call it fire, so that we know what it is. Now, this fire that we are looking for, what should happen if we press the W key? Well, it should be activated. So we're going to say If W is pressed, then fire should be set active. Now, fire active, just for you to know, fire active just checks if it's active or not. It doesn't set it. So we want to set active, and we want this to be true. With this, it's going to set our fire active if W is pressed. But let's go and check it first. So save your script, go into Unity, go into your game, and let's press play. So we are in play, we can play, but the fire is just active. Why is that? Well, it's active because it's active in our hierarchy. We haven't set it inactive. So if you want to set something inactive, you select it. So let's select the fire, and we make it inactive. But then there's another thing. We didn't tell the script what fire is. So if you click on Rocket and you go to your Rocket controller script, you'll also see that fire has nothing in it. There's none. So we need to drag our fire to this fire. So this thing tells us from our script where we've created this reference to a game object. Now we tell that script this object is what we want you to be able to activate and deactivate. So let's check it out now. So I'm in the game, I can move left and right, and once I press W, oh, there's fire. But the problem is the fire doesn't stop. Wow, what a great reference to a 1980s song. So the fire doesn't stop, so we need to make sure that the fire stops as well. And that is where the second part of an if statement comes in. So you can have an if, and then you can have an else. Again, with the curly brackets, everything in those curly brackets on this level is going to happen with regards to the else. Now, what else do we want to happen? Well, if it's not true, if it's not active, then it should be inactive. So we set that to false. And now let's move over, saving our script, going back into Unity and checking if this has solved our problem. So if I press W, I've got fire. If I stop pressing W, my fire stops as well. Excellent. Now we need to do exactly the same for the other fires and thrusters that we have. So how are we going to do that? Well, we'll just copy and paste this pattern. So here by our public game object, we need to create references to other variables as well, to other game objects. These game objects is going to be our left thruster, our right thruster, and our backwards thruster. My spelling is a little bit bad. So yeah, having a comma between these tells C# that, look, we want public variables of type game object, and these are the names that we want them to be. So if we save our script, go back to Unity again, if we click on our rocket, you'll see there's our references to all those thrusters. We can add them in here. So left thruster to left thruster, right thruster to right thruster, backwards thruster to backwards thruster. and we can deactivate all of these as well by selecting all of them and then clicking on this little icon that activates and deactivates it. Okay, so now our rocket in our game doesn't have any fire on it, so we need to go and program it. Remember to save frequently, Control S. So we've got some work here that needs to be done. So let's copy and paste this. And now we're going to do this for our left thruster. So we're just going to change the fire to left thruster. And left thruster, let's just go back to Unity quickly. The left thruster should be activated when you want to go right. So this is going to be D. So we want, when D is pressed, the left thruster should activate, taking our spaceship to the right. Similarly, we're going to do the same for the right thruster. So we just change that to right and right. And then this is going to be key code A. So we've got key code A to take our rocket to the left. Okay. And we're going to copy and paste this one last time because we also need for backwards. So this is going to be S. And we're going to use this as our back thruster. Now you'll see squiggly lines here. Why is it giving squiggly lines? If you hover over it, it gives you more information. So the name back thruster does not exist. So what did we call it? We called it backwards thruster. Now we can change this over here by just removing the backwards, and now that error should be gone. Let's head on to Unity, press play, and now we see an error. The variable back thruster of rocket has not been assigned. So we can move. Once we move, we see that there is thrusters being activated, but the backwards thruster isn't. Now what happened is that when we changed the script, the variable name, it changed it over here and it dislodged the object that we pushed in here. So whenever you change variable names, you need to be careful because it could change a lot of your game. So we need to add a backward thruster again. And let's try it now. So once we do that, no errors here at the bottom. We've got our backward thrusters. We can go left and right, and we can go up and down. Excellent. So our rocket is moving. We've got thrusters working in all directions. But one thing that we could do is we can simply go off the screen, which isn't ideal if you want your students to be playing this game. So we need to find a way of overcoming this particular conundrum. Now, I have to be honest here. I don't know exactly how to do it in a way that's going to look good. So what I did is I asked ChatGPT if it could assist, and lo and behold, it gave me some code that we can paste in, and we can try. Now, some of you might think that this is cheating, and probably it is a little bit of cheating, but I can promise you that in your journey as a programmer of games, you'll find very often that there is these challenges that you simply cannot overcome, that you don't have the knowledge how to do it. And that is where resources such as Stack Overflow and ChatGPT and YouTube tutorials are worth gold, because you learn through this process of seeing what others have done, and you can also reach out on these platforms and ask for others to assist you. So let's take a look at what ChatGPT suggested. So first and foremost, it said that we needed to have these these variables, that this is what we need. So it said screen bounds and object width and object height. Now screen bounds takes a look at the camera and sees where the edges of the camera is. That is what it does. So it generates points from the camera, and then these object width and object height, that gets the component of the sprite renderer, so the picture renderer on our rocket, because this is attached to the rocket, and it just gets the values of the x and the y there. So it determines how big our object is, and this determines how big our screen is, and we paste this in the start. We only need to find this once. Now we've got squiggly lines here. The reason for that is we haven't declared these variables, so we need to declare them. The first is screen bounds, that's a vector 2, because there's two, an x and a y. Is that correct? Now I'm second guessing myself. Yeah, it is a vector 2, because camera main screen wall to point generates a 2 dimensional vector. So vector 2 screen bounds, and then we need to create 2 floats as well. Float, and these floats is going to be object width and object height. Okay, so we've calculated what needs to be done, but now we also need to, in the update, make sure that within each frame our object doesn't move out of it. To do that, ChatGPT gave us also a little bit of code, and ChatGPT suggested that we put this in a late update. So again, I'm copying what was given to us by the artificial intelligence. So it is a late update. Now, how this works: starts runs only at the very first frame of your game. Update runs at each and every frame. But after an update has run, you can have a late update that's just before the next frame. And this only runs once, and so first you'll have an update running, and then you'll have your late update running. So we've got a late update here, and this is where ChatGPT's algorithm gave us how to clamp the sprite's position. So it generates a new vector 3, meaning there's 3 directions that it can go into. It clamps the x and the y position based on the screen bounds, the object width, and the object height, and then its position, it changes the position of the rocket transform position to this position that it created. So this is how it works in a nutshell, but let's check if it really works. So save, go into Unity, and it doesn't work. And that often happens. Now we need to do a little bit of error finding. So why does it not work? So we've got that. We've got a late update running there. And I found my error. So when I copied and pasted this late update, I pasted it in our update. So it is running in each update, which it shouldn't be. So just placing it beneath this bracket should sort out our problems. So saving again, going back, hitting play, and let's see now. There we go. So now our object stays within the screen, it doesn't go out. So problem solved. Thanks, ChatGPT. So we have our rocket, it moves, it's highly maneuverable, but what good is a good spaceship that doesn't shoot lasers? So next we need to generate something that's going to create lasers for us. So to create a laser, we need to drag in our laser onto the hierarchy. Now we can see over here is our laser in the game, but it's quite small. So let's extend it on the Y a bit. That looks good. And shall we do the X as well? Perhaps just a little bit. There we go. Now we've got a very nice red laser beam going out. Now again, if we were to hit play, absolutely nothing would happen because we haven't programmed anything yet. So to get our laser to do something for us, we can add a rigid body 2D. We can add the rigid body 2D, like I said, and we also need to add something called a collider, a box collider. So box collider 2D. Now what a box collider does, it tells Unity where exactly collisions can occur. And if you take a look at these green lines, that is where the box collider currently is. Now you can click on edit and make it bigger, but that would defeat the purpose because we want it to be on our laser. That is what's going to hit other objects. Now if we were to hit play, we would see that our laser just goes in the wrong direction. We can cheat a bit here. And what we could do is we can go into the rigid body and change the direction of gravity. So by making it a -1. So since gravity is always downwards, by changing the gravity scale to -1, it should move up now. There we go. So we've got gravity taking our laser away. So physically it's not correct. So if there's anyone with a physics background, I do apologize. I also have a physics background, but we cheat a little bit to make physics work for us in games. So now we've got a laser beam that goes up and down, and that goes away from our spaceship. But we would like to generate these laser beams more than once. Now we can copy and paste them, but that's going to take a very long time. So what Unity does is we can create prefabs. So by clicking on Assets, right-clicking, Create Folder, and we create a folder called Prefabs. Now prefabs are basically anything that you've got in your hierarchy and you drag them into your assets folder, and then it becomes a prefab. Now these prefabs can be used anywhere, and you can instantiate them, so you can create copies of this that's going to be exactly the same game object without having to go through the process of doing copies and paste. So let's delete that one, and as soon as you drag it over, you'll see that it's exactly the same as it was before. Now, to tell Unity where to instantiate, where to create the laser, we need to give it a reference point. Now, the lasers are going to be instantiated or created on the rocket. So what we're going to do is, on the rocket, we're going to right-click and say Create Empty. This creates a game object that has absolutely nothing on it, but we can add things to it. So we won't be able to see it, but we are going to be able to use it. And we're going to call this our laser spawner, because it's going to spawn these game assets for us. Now, if we double click on the laser spawner, we'll see that it's right here in the middle of our rocket, and we'd like to get it right at the top, so that it instantiates our laser beams right here at the top. So there we have our laser spawner, and as you might have guessed, we need to program this. So how are we going to program this? Well, we are going to create a script called laser spawner. Create an add. Right click, edit script, and that then opens it in Visual Studio. So in Visual Studio, we need to think a bit about how this spawner is going to work. Well, first and foremost, it needs to spawn lasers for us. So let's create a public game object for our laser beams. Okay, so we have that. And then we need to think about how often our laser is going to shoot. Because otherwise you can just keep your button pressed and it's going to spawn the laser all the time, and that we don't want. So let's think about that. So what we'll need is we'll need to have a time when the next fire can be shot, when the next laser can be shot. So we're going to keep this private. We're going to say it's a float because it's going to be a decimal, and then we call it next fire time. And we'll set this to 0 because we want our first shot to be right at the beginning of our game. Okay. Now for this, we're not going to be using the start or the update. So we can delete both the start and the update. And we're going to create a private, a new method called spawn laser. So it's going to be public because we want to call it from other scripts and other places. But it's not going to return anything, so we say void, and we call it spawn laser. We add these brackets and our curly brackets. So we have this. Now we are going to tell, we first need to check whether or not enough time has passed since our last shot. So we are going to use an if. Like I said, if comes up everywhere. So if, and then we want to check what is the time. So this tells us the exact time at the beginning of this frame. Okay, so if the time equals more than next fire time, you see here comes AI to our rescue again with Visual Studio. You can just double press tab and it adds that line, which is exactly what we want. So we want if time, so if the time now is more than the next fire time. Now the next fire time is the time that we can fire at. Then we want to have change our next fire time to something else. So we want our time, that is our time now, but we want to add something to it. So what we probably need to do is declare a rate limiter as well. So let's do that, and we'll do this as a public float, and we'll call it fire rate. And let's just make it 1 for now. So we say equals 1f. So whenever you're dealing with a float, you need to add a f after your number. So what we're going to do is we're going to say we want 1f divided by our fire rate. So what this means is that if we've got a fire rate of 20, so if this becomes 20, then our time is going to be the current time plus 1 divided by 20. So we can shoot 20 shots per second in this scenario. If our fire rate is 0.5, then it's going to be 1 divided by 0.5, so 2, so time plus 2, then it becomes, so only 1 shot every 2 seconds. So that is how we are going to limit our laser just a little bit. Okay, and then we need to instantiate our laser. So we're going to create a new game object, and we're going to call it laser. We're going to say instantiate. Instantiate means to create, and we want to create a laser beam. This laser beam is at our transform position. So just to show you, this class is attached to the laser spawner. So laser spawner, that class, that script is attached to the laser spawner. The laser spawner is here, and this is the transform position. So we want our laser beam to start off at this position. So if we change this, then it changes the laser position as well, the spawn position. So we want transform position, and then next we want to add a rotation. Now this is just one of those fillers. So quaternion dot identity. You can think of it as Oh, now my spelling has left me. Quaternion identity. You can think of it as a little bit of Harry Potter magic happening there. That just tells it that we don't want any rotation happening on our instantiated object. Okay, so that then generates a laser for us. But we still need to tell it when it needs to generate this laser. So most likely it's when the player is hitting fire. So in our rocket controller, we need to add our section on how to instantiate a laser. So that's going to be done via space, or any other key that you would like. But I think space is a good way of doing it. So we'll say if input.getKey keycode.space. So what should happen if space is pressed? Well, we want to have our laser spawner do this spawn laser thingy. Now we need to get a reference between the rocket controller and this laser spawner. So how are we going to do that? Well, here where we declare all our variables, we can do something similar for laser spawner. So we want a laser spawner, and we'll call it laser spawner. Make sure that you double check the capitals and small letters. Whenever we declare a variable, we do so with a small case. When it's a class like this, we do it with a capital. So laser spawner. And now we need to get a reference to that laser spawner. So we can just say, let's do it here, laser spawner, and so it's suggested that we do get component laser spawner, but this is not correct, because if we go back to our game, Rocket has the rocket controller, but there's no laser spawner script on Rocket. So if we do get component, it's going to look everywhere, not find it, and give us an error. So what we're going to use is find object of type laser spawner. And what this does is it goes through your whole hierarchy looking for a script called laser spawner, and it adds it in here. Now the risk is that it is a rather slow process, so you cannot do it if you are programming very big games. But in our instance, this is perfectly fine to do it like this. The other risk that you run is that you can only have one laser spawner in your whole game. If you have two, it'll only find the first one and add that, and that might lead you into a challenge. So if you only have one script, then you can do the find object of type. If you've got more scripts attached to different objects, or the same script attached to different objects, and you want to make sure that it's the right object, then you could rather use a public game object or a public laser spawner and add it via dragging. So we've got laser spawner there, and now we need to tell here in the space that we created, the space key, we need to tell it what it needs to do. So we are interested in a laser spawner, and we call this spawn laser. So we want spawn laser to run, spawn laser. We save our script. Let's head on back to Unity to check if this is working. So we've got nothing happening, and we've got an error that pops up here. The variable laser beam has not been assigned. Ah, silly me. So in your laser spawner, what we need to do is we need to add our prefab here. So just drag your prefab into here, and let's see if that works. There we have our lasers going through. Excellent. And it is limited, so I cannot just keep space pressed in and it fills up the screen. So we've solved two problems and we've got lasers. Now one thing that you'll see is that each laser that we create generates a game object here, and the more we play, the more game objects we are getting. So you can go and have a look, and this laser will still be going. It's past 5,000 on the y-axis already. So this will go on forever and ever and ever, and it uses a lot of resources. So that's not a very good programming style. So what we need to do is we need to check on the laser. After it's been instantiated, we need to delete it. Now, how are we going to do that? Well, let's go to our laser spawner. So we've got game object laser. This is the laser that we've created. What we can do is we can tell C# to destroy this laser for us. and to do so after, let's say, 3 seconds. So 3f, it's a float. So after 3 seconds, please destroy this game object, this laser for us. So let's check it out now. So we've got lasers forming, but then also being destroyed after a couple of seconds. So it's off the screen, it doesn't matter to us, we don't see that laser anymore, so we can ignore it. So we probably need to test these lasers as well, so let's make a quick and dirty object that we can hit with our lasers. So in your hierarchy, right click 2D game object sprite, and then we just want the square. So we've got the square and we cannot see it currently. I wonder why. Let's just check where it is. It's because it's on the Y very far. So let's make it 0, 0. There we go. And let's move it up a bit. And let's see what happens if we try and hit this square with our laser. Well, it simply passes through. Why is that? Well, because our sprite currently doesn't have anything on it. So we need to tell Unity that this needs to have a collider on it. Now let's try it again. So as soon as we've got a collider, it stops our laser dead in its tracks. But it doesn't look quite realistic. So we need to find a way for our laser to actually do damage to our square. Now, to do that, we need to add a script to our laser. So in your assets prefabs folder, click on your laser and add a script called laser beam. Create an add. Let's edit the script. So right click, edit the script. And here we have our laser beam script. So on this laser beam, we're also not going to be using the start and update methods. What we are going to use is we are interested in the collider that we've attached to our laser. So if we go back to Unity, if you take a look, we have this box collider that tells Unity whenever there's a collision that happens. So we are interested in that, and Unity provides us with a particular script that checks whether or not collisions are happening. So what we could do is we could say on collision enter 2D, and that generates a new method for us called on collision enter 2D, and it's got this collision 2D collision in the brackets. Now this tells us that once this object, our laser, hits something, it looks at what it hit, and this is what that collision is. So if we hit this collision, well, what do we want to do? We want to destroy it. So let's destroy the collision game object. Aha. So that destroys the collision game object. Now we could go back into Unity, check it out to see if it works. And there we go, it destroys it. But the laser just goes on. And as far as my physics knowledge goes, the laser should dissipate as well. So we need to destroy this game object as well. So this game object, meaning this laser. So we destroyed this laser as well. Let's check that again in Unity to see how that looks. boom, there we go, it's gone. But what good is it that we just destroy these objects without a little bit of an explosion? So what we need to do is we need to find explosions. Now we can create this from from ourselves, or we can use another cheat method. So this is a pretty legal cheat method. If you go to Window and then click on Asset Store, it'll give you this button that you can press to search online, which opens the Unity Asset Store. Now you might need to log in. Please do so if you haven't logged in. But the Unity Asset Store has access to loads of different bundles and tools to make your life a whole lot easier. So you'll see there's 2D platformer tile sets, dungeon tile sets. So if you are interested in making good quality games, you'll most often come to the Unity Asset Store. We are looking for explosions. So let's type in explosions, and we can see, wow, there's lots of different explosions happening, but we are only interested in the 2D ones. And again, here's a whole lot of different explosions, ranging in price, but over here we've got a free assets option, and here we've got different explosions. So here's a 2D spaceship game. If you want to download that, you can use these assets as well. Here's a 2D flat explosion. Let's add 3D because sometimes we can use 3D explosions as well. So you can take a look, you can play around with some of these things. Main thing is just make sure that you don't spend too much money on this, because it can get quite expensive. And sometimes you need to think a bit out of the box because people call their things something else. So I'm looking for a particular package that I got a while ago, that has quite amazing explosions, and it's called Free 2D Impact FX by Ingus Media. Now you'll see mine is already purchased, so you might have a little bit of a different look, but what you need to do is need to open this up, and here's a video of the different explosions that he's created, or they created. And what we want to do is then click on the purchase option. So you'll go through the process of purchasing it. It's not going to cost you anything. And then once you've got this Opening Unity button, you press that and you select Open Unity Editor, which then opens up the package manager for Unity. Okay, once you've got the package manager open, you'll click on Download here at the top. So you'll click on Download, it'll download the files. You'll hit Import, and then you'll be faced with a screen that looks like this. So you'll see Ingus Free 2D Impact FX, and you'll click on Import, and this then imports all of those wonderful files that has been created by someone else. Now again, I cannot go through the whole asset store with you because there's just too many different amazing things there, but I can show you how to incorporate some of it. So here we've got Ingus Media Studio. If we double click on it, there's a few different files. So we've got a demo scene. We're not interested in the demo scene. There's materials and scripts and sprites. What we are interested in is the prefabs. So here's free prefabs, and we can drag these prefabs to our our main game and check them out. And you can choose any one of these prefabs as your explosion that you'd like to use. So you can delete these from the main game, take these prefabs over to your prefabs folder, and then we can play around with which one we want to use for our explosion. So back to our laser beam. Once we've destroyed something, we want to create an explosion. So again, we are going to create a public game object. This is going to be explosion. So what we are going to tell it is we want to have a game object kaboom. We can call it literally anything. And this is going to be an instantiation of explosion. We wanted to have it at the transform position and the quaternion identity of the laser beam. And let's save this, go over into Unity, select our laser beam because that's where our laser script is on, and we choose one of these explosions and drag it onto this laser beam. So now we've got a prefab in a prefab, and let's see if this works. And we got our explosion as expected. Woohoo! So although we've got an enemy in our white square, we probably need to make it a little bit more engaging at this stage. Now let's give this this enemy of ours a name first and foremost. We'll call it an enemy. We've got our enemy, and now we need to add a script to our enemy as well. As with anything we do, we add a script if we need it to do something very particular in our minds. So edit script, and what we need our enemy to do is basically just to move down the screen. So that is in essence what we need from them. So let's get a speed variable because it's always good to have a speed. So we'll do public int speed, and we'll make that 2 for now. You won't be using a start for this, and the only thing that needs to happen is these enemies needs to move from the top of the screen downwards for us. So we are going to generate vector 2 meaning there's an x and a y, new position, going to be a new vector 2, so something new that we create, and it's going to be our transform position x. Remember, this script is on the enemy, and we don't want them to move any way on the x-axis at this stage. And then we want the transform position y to change. So we want this to change by the speed that we give. And then we use something called time.delta time. This just means that it needs to move by the time that it takes for that frame to pass. Not each frame passes at the same pace. So sometimes it might be a bit quicker and sometimes a bit slower. and we want to even that out, and that's why we use time.delta time. And here AI tells us, okay, we want to transform the position to the new position. That is exactly what we want to do. So if we save this and head on back to Unity, we'll see that our enemy is moving, which is what we'd like. If we restart, we can shoot our enemy as well. So we've seen some movement, but yeah, this little blocky thingy doesn't work for me anymore. So let's change out the square sprite. So selecting enemy on the sprite renderer, going here, you can see all the different sprites that is available to you within this particular game. But we can also go to our sprites and let's select our UFO. So there we have our UFO. Now currently it's quite extensive. So let's make our enemy a little bit smaller. To 0.2. That might be a bit too small. Let's do it 0.5. 0.5. You can play around. It's your game. So you can make it as big or as small as you'd like. Okay, and let's play this now. Excellent, we've destroyed our first UFO. Now there is something that we need to keep in mind though. Because we did it like this, if we were to shoot here on the side of the UFO, it would just pass through. And the reason for that is, if we take a look at our, let's just double click, if we take a look at our box collider, this box collider is only on this small little segment over here. So if you don't hit it right at the center with your laser, it's not going to do anything. So we need to edit the box collider, make it a little bit bigger to include all these angles. Ah, shucks. I'm a terrible shot. And there we have it. So there it destroys our UFO anywhere that we hit it. Now one thing that's bothering me is that if we hit play, the UFO can simply just pass through our rocket. Now why is that? Well, the main reason is our rocket has a rigid body, but it has no colliders on it. So we need to add a collider to our rocket. Now you can use a few different types of colliders, but in this case we are going to use what is called an edge collider, because our rocket has a few interesting edges, and we want to make sure that if a UFO touches anywhere on our rocket, that it does have an impact. We are going to use an edge collider. How an edge collider works, let's go to our rocket, is by clicking on edit, you can draw collider to fit roughly around your rocket. You can be as detailed as you'd like. Ultimately, we don't want to use too many of these because it does come at a computational cost. But it gives you a lot more realistic approaches and interactions if you have the proper colliders on. So a box collider could also work, but then if a UFO were to hit it here and the box collider is here, then it would generate an impact for your spaceship, and many people might be a bit negative if it doesn't really hit them. So there we have our collider. Now if we were to play, we would see that our spaceship can be hit by UFOs. Which brings me to another point. In our game, we don't have any rotation at this stage because it's just an introduction. So we need to keep our rocket centered on one axis. And to do that, we enter into the rigid body. And under constraints, we can say freeze rotation. So now, no matter how hard the UFO is pushing us, we won't rotate at all. We need to probably do the same for the enemy as well, but at this stage we can just skip that. So let's see. Oh shucks, what happened there? So when I press space now, I explode. I wonder why is that? Well, it's most likely from our laser that we instantiate. So that laser, in that very split second, interacts with our collider that we've just attached. So if we were to switch off our collider and play again, the laser goes through. But if we have our collider on, it works sometimes and sometimes it doesn't. Let me just, it's off. So when the collider is on, then we explode. So we need to find a way around that particular conundrum. We can do that by changing some of the settings on our assets. So let's go to prefabs and now we go to our laser. We're going to change the layer on which this laser is. So we are going to say add a layer, and we are going to name this layer laser. So there we go, we've done that. And then on the rocket, we are going to add a layer and call that rocket. Now we've named it, but we should add it as well. So go click on your rocket, go to layer, add rocket, and say yes, change children as well. And then on our laser, which is in our prefabs, go and make that a laser. Now that in itself won't stop us from exploding by our own laser being projected into us. So what we need to do is go to Edit, and then go to Project Settings, click on Physics 2D, which opens up the general settings, and here you can play around with different physics settings, so anything from angular corrections and velocities and gravities and things like that. You can play around with that. But what we are interested in is the layer collision matrix. And this tells Unity what layers can interact with one another and which shouldn't. So we don't want our own lasers to interact with our rocket. So if we take a look here, we've got our rocket and a laser. So we don't want those two to interact. You can close this window now. And now, let me just check, is our rocket Edge Collider enabled? Now, with a little bit of luck, our lasers won't be killing us anymore. which is a big plus point when you are traveling in space. So having one UFO is fun, but having more might be even more fun. So let's create a enemy spawner. We've got a laser spawner, why not an enemy spawner? So to do that, we need to create a prefab from our enemy by dragging it into our prefabs folder. So assets prefabs, make sure that you drag your enemy in. Now we've got an enemy. We can delete this little guy, much more humane than using lasers to kill them. But yeah, now we need to generate a empty object again. So we've created an empty object, and this is going to be our enemy spawner. Let's see where our enemy spawner is. Now we don't want our enemies to spawn randomly in our game. So we'll take our enemy spawner up to above our game window. So I'm at position 7 roughly. I think that is perfectly fine. And then we want this enemy spawner to obviously have a script. So enemy spawner script. Right click to open the script, edit script, and here we have it. Now we already have a laser spawner, and basically what we're going to do is just copy and paste this because we've already done it. We don't need any of these. We'll just do a little bit of our own homework. So let's see, this is going to be enemy. We don't want fire, we want next enemy time. And we'll have our enemy rate. Now we just need to update all of these. Next enemy time, enemy rate. This is just going to be our enemy. Enemy time. Okay, and this destroy function, we should probably just double check if it's enough time for the enemy to move from the top of your screen to the bottom of your screen. I think we should increase this. Let's make it at least 10 seconds. It's quite a lot, but then we know the enemy has completely passed. Okay, let's go into Unity and let's check this out. Okay, so we see that nothing is happening, and that is probably because we didn't tell our enemy spawner what our enemy is. So how can it spawn it if we didn't tell it what it is? So we add the enemy. And now we see there's no enemy spawning. Why is that? Okay, so going through the script, I see this should be enemy. It's not going to affect us because we create this name. Game object enemy 2. We can just call it enemy 2 now. 2. Instantiate enemy. Let's save the script. Try it again. Okay, and again, no enemy spawning. So sometimes strange things happens in games and you don't know why. And what you can do in such instances is you can use the debug function. So there we go. Okay, so it's not it's going to be enemy. It's perfectly fine. So we've got, I've now realized, so we've got this function, public void spawn enemy, but nothing calls this function. So we need something to actually tell it that it's okay for this function to be called now. And that's not going to work in this instance. So we copied from our other spawner. Our other spawner had this public void spawn laser that was called each time we pressed space. This is not the case for our enemies. We just want them to come. So we'll do this in an update. So sorry for deleting the update, but there we go. And I think I might be right in saying that we should be getting enemies now. And there we go. We've got enemies coming through. But these enemies are just coming in one straight line, and that's not very smart, even for the fact that they've got flying saucers, and now they're just coming in one straight line. So we need to tell our enemy spawner to move around a bit. Now we're not going to move it on the y-axis, we're just going to move it on our x-axis. And we can do this by changing the position. So what we are going to do is just say transform.position. Remember, this is the spawner that the script is attached to. So we want to transform the position of the spawner, and we want to do it to a new vector2, and this is going to be on the x-axis. We want it to go left and right, but on the y-axis it's going to remain the same. So let's say we want this to be random. So random range. Now we need to tell Unity what the range should be. So if we go into Unity and we just drag our spawner, we can see that the maximum it can go is up to around about 9. This is where it cuts off here. So I would say that our UFO should come up to 8, and then it would also be -8. So we can then insert our random range from -8f to 8f. So now it's going to be randomly between those two values, assign a value and position the spawner there, and our transform on the y is going to remain the same. So we keep that as transform position y. Now remember, this transform position y sounds very strange, but in essence what it is it tells it enemy spawner transform position y should remain exactly the same. So that's how that functionality works. So we've got that, and we are missing a semicolon. Let's save it and go back to Unity to see how this looks now. And here we go, we've got our spaceships coming through left, right and center. Now you can play around with this enemy rate. We can make it 5, for instance. Make it 0.5. See how that impacts your spawner. Now let's just also check. We've got all these clones, enemy clones, going down. So we need to make doubly sure that they are destroyed as well. So let's go into our script and let's destroy our enemies. 2, destroy enemy 2, and we want to do this in, let's say, 10 seconds. So it's going to destroy the enemy in 10 seconds, and it generates this new position. And that's it for the enemy spawner. Now, something that's bothering me a bit is when we've got our enemies coming through and we hit them, nothing really happens. So there's no incentive for our students to actually hit the enemies. So we need to cause some damage to our spaceship when an enemy hits. Now, to do that, we'll go into our rocket, into our spaceship, into our rocket controller script. And what we need to do is we need to find a way of looking whether or not there has been any collisions with our ship. So we can do that with the on-collision enter method. So on collision enter 2D, please don't select just the on collision enter version. I did it, and it took me nearly 3 hours to figure out why my script isn't working, and it was just because I missed this little 2D thingy here. So if what happens here is if something hits our rocket, it's going to activate this particular piece of code. So we are interested in checking whether or not what has been hit is actually our enemy. We can do that by saying if collision. Remember, this collision is what hit our script, our object that the script is attached to. So if collision, we are interested in the game object of that collision and the tag thereof. If this is enemy, then we want to do something. Okay, now before we go any further, we need to check whether or not our enemy actually has a tagged, and no, it's untagged. So in prefabs, under your assets folder, you'll see tag untagged, and there's no enemy option. So we can add a tag, click on plus, and then say enemy. Remember, it should be case sensitive, so enemy with a capital letter. So we've got a tag created. Now you need to go back to your prefabs, make sure that enemy is tagged as an enemy. So we tag it as an enemy, and now each time we hit an enemy, we'll go into this particular piece of code. Okay, now what exactly do we want to do with this enemy hit? Well, we can do a debug.log saying that we hit a UFO, just to check if everything is working. Now if we go back to Unity, we play, and as soon as we hit, you'll see there we get a hit UFO. So that piece of code is indeed working. Road to Mars. Okay, so now we can remove that, and this is a quick and easy way to check if something particular is working. You can just add debug.log and then type in what you want it to say. So we've got collision game object tag enemy. So what do we want to do? Well, first of all, our spaceship is stronger than that of the enemy, so we want to destroy the collision game object. So we destroy our enemies. But again, we want a little bit of an explosion, so we are going to use that explosion that explosion that we wrote, that was on a different script. It was on the laser. There we go. So we can use this again. So we'll use the game object kaboom. Okay, now it tells us that the explosion doesn't exist because we haven't created a game object here that's called explosion. So it's going to be a public game object explosion. We save that. So we create this game object called explosion. We destroy this game object, kaboom, after 4 seconds. This is just to keep our hierarchy without a lot of dead things. And yeah, let's see how that works. So we can go onto Unity. Now what we need to do is on our rocket is go and check that we have our explosion linked up here. It's on rocket controller, so there's no explosion yet. So let's use this one. You can use any of the impacts that you want. Okay, so it does generate an explosion, but just on the wrong position. You'll see that the explosion happens here at the back of, in the middle of our spaceship, and we don't want that. We want it to happen where this impact is happening. So go back to our code. Let's check. So here's where we instantiate it. We instantiate this on our rocket ship, and this should be on the collision. So we can say collision.transform.position. Save your script again. Head on to Unity. Let's see if this now generates a better looking explosion. There we go. That looks a lot more realistic. Well, as realistic as computer games can be. So there we go, we've solved that challenge. So we've generated that, but what's the use if we can just merely create all of these different, we can just run through all the UFOs. So we need to keep track of how good we are doing. We can do that by creating a form of measurement. So let's generate a what are we going to call it? Is it going to be a scores manager, I think. Okay, let's create a scores manager, and again we'll create the script for the scores manager. We'll edit this script. Okay, and this script is going to take our health as one of the variables that we are interested in. So we want to have a score. Let's do a score, public int score, and we'll set that to 0 at the start of the game. We don't want our score to be too high. So we'll have this, and then we need to create 2 methods. We need to create a method that increases the score, public score, And here we are going to tell it how much it should increase with. Okay, so we say we want an int, increase score, and again AI for the win. We've got score plus equals, this means score plus this increase is going to equal score. So we've got that. Now we need to we have a decrease score as well. Void decrease, there we go. Decrease score. And this is going to be score minus equals the decrease score. Okay, so there we have it. We've got an increase score, a decrease score, but we also need a way of showing what our score currently is. And this can be done in Unity using what we call the user interface. So in your hierarchy, right click, go to UI and select Canvas. Now this generates a massive canvas. So to give you an idea, our whole game is in this space over here, and this is the canvas that we create. So it's not a physical game object, as is the case in with our sprites. This generates a canvas that we can interact with our users. Our users can interact with. And one thing that you need to do is you need to change this constant pixel size to scale with screen size, and set your reference sizes here. So it's 920 by 1080. This is a standard HD screen which we are developing for. So now we've got this canvas, and we can add, if you right click on the canvas, you can add different things. So we want to add text in the form of TextMesh Pro. Now as soon as you do that, it pops up this little block. So you just say import TMP essentials and close it, and then you have text that you can position in your canvas. Now we can click on this text, and then on this button over here you can center it wherever you want. So if you hit Alt and click there, it shifts it to the left hand corner. So we've got it shifted there, and now you can position it as you like in that particular corner. Okay, you can also play around. We can make it bold, we can say auto size, and we can make the maximum 100. So there we have it, and this is going to be our score. So we have our score, but then we also want to update this using our scripts. So you can copy the score and then just drag it over to the right, and this is going to be 0. So we've got a score of 0. And if you'd like, you can change this to any color you'd like by clicking here on the vertex color. Let's go for a nice green, and there we have our score. Now we probably need to have something similar for our health as well, so we can just select these two, Control D to copy them, and then shift them down to have our health. Now we need to do our housekeeping. So this is going to be the score text, and this is the score value. This is going to be our, shall we name it shield? I think that might be a good way of going about it. Shield strength, and this will be our shield value. Okay, so we've got scores and shields, and this is now on our canvas. And no matter what size your screen is going to be, it will always be in the left-hand corner right there at the top, looking for you. So if you'd like, you can change the color of the shield to something else. You can play around. It's your game. Okay. So we have our canvas. Once you add a canvas, it adds an event system as well. Don't worry about that. That you can just leave like it is. And on our scores manager, we now need to tell it how to update our UI. So here, right at the top, we are going to say using Unity Engine.ui. This tells it that it needs to include all the libraries for the UI as well. Now remember, we added TMP Pro, so that was our something that we added as well. So we need to say using TMP Pro as well. Just in this instance, because we are going to work with with TMP Pro, and now we need references to our score and our shield. So we'll do public text mesh pro, and we are working on the graphical user interface. And this is going to be our Shields UI. We can copy this. Yes, we will also do the Scores UI. Okay. Now at this stage, we are only going to do the Score AI. We'll do the shields a little bit later on. But in our update, we want to update that text every single second. So we'll do score UI text. We are interested in changing the text. You can change the color and things like that through the script as well. We want to change the text score, and the score needs to be converted because it's an integer. It needs to go to a string. So whenever you want to display any integers or floats, you need to add this to string, and that then generates that generates a string. So we can save that. Now, when will our scores be increased and decreased? Well, it will increase most likely when we kill one of our enemies. So when do we kill our enemies? Well, we kill them if a laser explodes with them. So we need a reference here to our score manager. And we need to tell it where to look for it. So score manager find all, or find object of type score manager. So that searches for our score manager. We only have one score manager in our game, so it'll work. And then on collision enter of a laser beam with something else, we want to increase the score. So we say score manager, and it's going to be increase score, and we want to increase it by 150 points. Why not? So we've got score manager increase points, and that then happens. But now we also want to decrease points. And when are we going to decrease points? Well, we are going to decrease points each time our player interacts with an enemy. So we need to reference our score manager here as well. The AI helps us again find the score manager. And then here where we have our collision, we want to make our score less. So score manager, decrease score, and we can decrease our score by, let's make it 250. Okay, let's see how this works. See, we've got an error, object not set to a reference. That's because our score manager doesn't know which is the shield, so we need to insert that. So score UI is that score value, shield is that one, and let's see now. There we go. So once a UFO hits us, we lose 250 points. Once we shoot, we gain 150 points. So we've got a game, people. We've got a game because there's a reward for and a detrimental result. Now we need to add the shields as well. So let's do the shields quickly. Okay, so our game is going quite well so far. We've got thrusters, we can shoot, we've got scores happening, we can lose scores, we can go into negatives, but we need to work on our shields because ultimately there needs to be a game over option for this game of ours. So to do that, we need to go into our rocket and on the rocket controller, because that's where it makes sense that we have our shield's power. So let's let's create a variable that's going to be called public. It's going to be an integer, and we'll call it shields. And we'll set this to 100. Okay. So there we have it. Public shields is 100. Now, when do we lose shields? We lose shields whenever an enemy hits us. So we lose score, but we also lose shields. So we'll say shield minus equals, and our shields, let's say our shields goes down by 15 for each hit that we receive. So we have our shields going down. Now we need to get a reference here to the rocket. So we'll say private rocket controller rocket, and we'll take a look for our rocket. Find object of type rocket controller. Then we want to say that our shields UI, remember this is just where we update we update our UI. So our shields UI is going to be our rocket, and what we are looking for on our rocket is shields, and we need to move that to string as well. So now let's take a look. If we play, So our shields are updated to 100. Once we hit, we lose some of our shields. It's going down quickly, and then as soon as we hit negatives, we should explode because we don't have any shields left. So let's go into our rocket controller, and what we are going to do is in our late update, we'll check if shields is less than 0. Then we need to destroy this game object. Okay, so if our shields is less than 0, we need to destroy our poor little rocket. Hopefully it's not going to happen. Let's check out if that works. So you'll see that every time I do something, I check first if it works. I know it's a little bit pedantic, but ultimately, if you do a lot of editing and you get to a stage where you don't know what's happening, there we go. So we exploded as well. When you've done a lot of editing, error tracing becomes a big issue. So rather sort out as you go along, instead of just going full smack bang and then trying to sort out everything. So here we destroy our rocket when shields are low. Okay, we can probably make it a little bit fancier by adding another explosion. Let's add explosion 2 here. So it's going to be game object kaboom 2 equals new kaboom explosion 2 transform dot the position and fermion dot identity. It's not going to be new game object, it's going to be instantiate. Instantiate this, and then just for housekeeping, we'll destroy kaboom 2 after 2 seconds. Okay, so let's go and blow up a spaceship. We didn't. I forgot again to add our game object. So we've got explosion 1. We need to add explosion 2 as well. Let's check it again. And there we explode. So that is working great. So we've now got a threat to our survival. We need to make sure that we don't hit any of those UFOs. So we've got a game, but we want to create an educational game. And to do so, I often find it easier to work with the bonus, the rewards, to entice our students and to allow them to play, to actively want to get bonuses and to get rewarded. So let's create a bonus or a reward for our participants, our players. So in your sprites folder, you'll see there's a little star. You can use any image that you want. You can go onto the internet and find some other places or some other images if you'd like. And let's make it a bit smaller. So this is going to be our upgrade. And to get an upgrade, a student would need to first catch the star, then they need to answer a question correctly. They can try all the answers, but ultimately they need to get it correctly. And through making mistakes, they'll learn. So we've got our upgrade sprite that's now here, and this sprite we need to upgrade. We need to upgrade our upgrade by adding a script to it. So let's call this script our upgrade script. And let's just wait a second for it to finish hashing. Let's open up the script, edit script. So there we go. We've got our script. Now this upgrade script is going to help the sprite move in our game, and this is exactly the same as our enemy script that we previously created. So we can just copy this and paste it over into our upgrade script. And there we have it. So now our upgrade should move downwards if we go into play. So let's see. So yeah, there it moves downwards, and it goes in a similar manner as our UFOs, which is what we wanted. Similarly, we need to add a collider to this, and for the sake of time, we'll just do a box collider. And let's check if this box collider lines up, and that looks pretty close. So your hardcore players will perhaps moan a bit, because if you enter into any space that's not within the star but within the box, they'll get rewarded. But I think for the instances of our game, it's perfectly fine. You can use another collider if you'd like to, but for now we'll just use this box collider, and that then generates a box for us. Now we've got a enemy spawner, so I think we need to create a bonus spawner as well. And what we can do is we can just copy our enemy spawner and make this our upgrade spawner, and then we can create a prefab from this upgrade by dragging it into our upgrade, our prefabs folder, and then selecting this prefab to go into our spawner over here. Now this is called enemy spawner, but it does exactly the same job. So we'll just rehash this, and we'll make do with the fact that it's called enemy. Here we know better, so let's make that a 0.3. We don't want our enemies and our bonuses to spawn at the same rate, because otherwise it will be too easy. And here we go. So we can shoot our bonuses as well. That is just to keep people from doing the random shootings things. I think our bonuses are still a little bit too much, so we can reduce that rate over there to 0.1, for instance. making it a little bit harder to get a bonus. Okay, and that is how it works. Okay, but there is this issue that if we do go into one of the bonuses, we don't collect it. So we need to finalize that. And that we'll do on our rocket controller. So similar to how we did this on collision test. Where is that now? On collision enter 2D, and we tested if the game object tag was an enemy. We can now do something similar, this time just for our bonus or our reward. So we can add a tag reward, and now we need to make sure that our upgrade, oh yeah, it's upgrade. Let's keep it to one word. Upgrade. Now we need to create a tag for upgrades as well. So we add a tag upgrade. We save that. Remember that it needs to be it's case sensitive. So you need to make sure that it's selected and it's case sensitive, correct. So there we have our upgrade. And now in our script we can say, okay, if collision game object tag equals upgrade, what needs to happen? Well, we need to destroy this upgrade. That's perfectly fine. We are not going to have a explosion. We can delete that. Once we've deleted that, there's nothing to destroy, so we can delete that as well. Now here we've got a score manager decrease. This should be an increase because we've received a reward. So we can increase our marks, our score by, let's say, 300. And we're not going to do anything with the shields. Let's make our shields just a little bit stronger. So we say plus equals 5. So our shields will get a little bit stronger. Our score will increase substantially. And we can then activate a upgrade as well. So what can this upgrade be? Well, something that could be nice is to have a triple laser for a few seconds, and that's exactly what we'll do. So heading back to Unity, we'll go to our rocket, and then we need to create an upgrade for this rocket. So in our sprites, there is a triple laser image that you can drag and drop onto the rocket. We'll need to position it at 0, 0, 0 again. And if it doesn't show, just make the layer to 1. And let's see what is our problem now. Let's zoom out. So this is way too big, so we want it at 1, 1. Okay, let's see. Okay, let's position our triple laser. And we'll make this on order 0. Okay, so now we've got a triple laser that's added to our itinerary, our artillery, and we can now start programming this triple laser. So on our laser spawner, this is where we generate a single laser, but now we want to generate a triple laser. So we need to go in and rehash this script a bit. To do so, what I first want to do is I want to check if we've got our triple laser activated. So game object triple laser. And then we also want to have a upgraded laser, so we'll do game object laser beam. Okay, so we've got our triple laser game object and our upgraded laser beam object that we are interested in. Now, what we need to do is here in our spawn laser, we've checked whether or not we can shoot, but now we need to check if that triple laser is active in the hierarchy. So over here, we'll do if triple laser, and then we say active in hierarchy. This checks whether or not the laser is active, whether it's set to active or not. And if it is, if it's not, so if you want to have it as not, you just simply put a exclamation mark, meaning if this is false. So if triple laser active in hierarchy is false, then it should do the following. So we want to generate a laser and we want to destroy that laser after a couple of seconds. This is for a single laser. Now, if this is active, meaning else, then what we need to do is we need to instantiate our triple laser. This is going to be our upgraded laser beam, and we can keep that exactly as it is because it's going to spawn at the position of the laser, and then we need to destroy this triple laser again after 2 or 3 seconds. Okay, so that's the script that we need. Now in Unity we need to tell it a few things as well. So let's go to our laser spawner. Now you'll see that we've got triple laser and we've got upgraded laser beam. Now this triple laser is this game object that we added our guns over there. So we want to know if this is active, then we should have this upgraded laser. But we don't yet have the upgraded laser, so we need to check how to create that. And again, what we'll do is we'll generate a new prefab. So let's use our laser beam, and we'll generate a empty game object. We'll call this triple laser. And this triple laser is actually going to contain 3 of our laser sprites, our prefabs, so our laser beams. So we'll add 3 of them. Okay, now we just need to position these quite well. So one is going to start off there, one is going to start off here, the other one will be starting from here. Okay, so this is now our triple laser. Let's see how that works. Well, before we go, we need to set our triple laser as a prefab. We can then delete this, and in our rocket, in our laser spawner, we need to add our triple laser to this upgraded laser beam. So let's see if this works. So it does generate, but it generates the lasers at a incorrect space. This you need to rectify by going into our prefab. So let's get our lasers out again. So this laser spawns there. Let's make it like this, and then we need to go to our laser spawner, check what is happening here. So the laser spawner sits over there. Our triple laser needs to be positioned there. And let's check now if that works. Somehow it looks worse. And again, this is how coding works. Sometimes you get stuck with a simple issue like lasers not lining up, and you need to go and find where the issue is arising from. Okay, so this problem can be solved by double-clicking on the triple laser that you created, and then whilst you're in play mode, selecting all three of these beams and positioning them so that they align with your shots. So if we were to do it like this, you can see that it positions it quite poorly. So it needs to be well positioned whilst in play mode. Now, since we are editing the prefab in play mode, it should work if we exit play mode and go back in to Unity. There we go. So we've got our triple lasers working. Now these lasers cannot work for forever, so we need to have a way of allowing them to come up and then go away. So let's deactivate our triple laser, and then on our rocket we'll go into the rocket controller, and this is where the upgrade is. So what we want to do is we want to activate that game object that is our laser. So we'll first need a reference to that laser, that triple laser setup. So we'll say public game object triple laser. Then in our script here in the upgrade, we want to activate that triple laser. Set active to true. Okay, so now the laser is active. Now we need to have a way of deactivating it after a certain time frame. And that we do with a coroutine. So we'll say start coroutine, and we'll give this coroutine a name. So this will be deactivate lasers, and we'll open up our parentheses. Now, a coroutine is something that runs together with your script. So it's basically a second piece of script that's running. So you create a second a way of managing certain activities. Now what we want to do is we want this to run for a few seconds. So we'll say IE numerator. That is how you refer to a coroutine. So I don't know why they chose this name. And now it needs to be exactly the same as the activate lasers. Exactly the same as what you wrote there at the top. So we've got IE numerator, deactivate lasers, and every coroutine needs to return something. So in this instance, we'll say yield return new, wait 4 seconds. We'll do this. Let's give him 5 seconds for the triple lasers to be active, and then we'll switch off the lasers, the triple lasers. So triple lasers set active to false. So after 5 seconds, the triple lasers will deactivate. If we go into Unity, we need to make sure that everything is set up with our rocket, so we don't have the triple laser, so we'll just add a reference to this triple laser over here. And do we need anything else? I believe that is it. So let's check it out. If we get an error, we can just fix it. That's the beauty of working in... Okay, so yes, we still need to find a way to interact with our rewards. Why did that reward not work? Because it's untagged, so we need to create that as an upgrade, and now it should work. So let's see, there we go, we've got our upgrade, and we can now shoot 3 lasers for 5 seconds. There, it's deactivated. We've got our lasers again. So now the game is becoming quite fun, but we still need the educational aspect to make this a truly exceptional game, and we can do that by adding a few questions. So our questions, we'll ask multiple choice questions in this instance, because typing is often too tiresome for students whilst they're playing a game. So unless it's a very interactive story type of game, multiple choice questions or quick answer questions are normally the go-to. So what we'll need to do is we'll need to create a second canvas. So go to right-click UI and we say canvas, and this will be our question canvas, and we'll make this question canvas 1. Now for question canvas 1, what we want is we need to add a few things, the first being a panel. So a panel is basically just a way of organizing your UI into certain segments, and as soon as you add a panel, it'll spread across the whole canvas, so you'll see this white overlay. So we don't want that. We want this panel to be at the bottom. So we type in, hold Alt, and then we stretch it at the bottom. This one over here. So now it's stretched over the bottom. And if we were to decrease the height, you'll see that it decreases. There, we want to position it at 200. No. Let's take this up. So we want our questions to be here. Let's make this height a bit more, so 150, I think that's good. And we want to have cutoffs on the left and the right. Let's make it 50 and 50. There's our first panel. So what we'll have is our answers will come in here, and then we'll have a second panel. This panel will be linked to the top, so again Alt and hit the top. Okay, we want it a bit down. So this will be our question panel. And our question panel we'll even make a little bit smaller. So we'll increase the X let's do it by 50, and Y by, no, these panels, let's see, it is this panel, we want it stretched at the top, there we go. We want it 100 on the left, 100 on the right, we want it to be 150, and we need to move it a little bit down, so this is going to be our question panel. Let's just move it up. So we've got question panel and answer panel. Okay. Our answers is going to be 4 buttons, and we right click on answer and go to UI and say button Text Mesh Pro. So we've got our first button. Now we can make this button, our height is 150. Let's make this 120 by 120. Okay, and then we want 4 answers, so it's multiple choice, and we want 4 answers. Now these buttons are all on top of one another, and if you click on the answer panel, you say add component, and you say vertical layout group, it'll, horizontal layout group, it'll add your buttons in a horizontal manner. We want it to be centered in the middle, and there we have it. So here we have our buttons very nicely sorted. In our question panel, we'll add a UI text. We'll select this icon over here and make it stretched. So Alt and this one here, so it stretches all across the whole panel, and then we select center and center. Now let's do a black text, and we can make this panel white, and you'll see that there's some blackness coming through. That's because of the alpha value. So the alpha tells it how full it should be. So we want to increase the alpha there. So we've got black text on a white background so that it's nice and legible. We can make our question bold, and then we have our answers. Now we said that this is going to be about photosynthesis, so I asked ChatGPT to generate me a couple of quick questions. If you'd like, you can make your own questions up. It all depends on what you want to do with your game. So it all depends on what it is that you want to do. So let me just get my questions ready. Okay, so my first question is, what is the main product of photosynthesis? And what I do is I click on the text. Here in the text input, I just copy the question. What is the main product of photosynthesis? Now we've got 4 answers, and to get the answers, we'll need to open up these buttons to get to the text, and then we can copy and paste our answers in here. So we've got carbon dioxide, nitrogen, oxygen for number 3, and hydrogen as number 4. Okay, and let's just label our answers. Answer button 1, answer button 2, answer button 3, and answer button 4. So there we have our question and our answers. Now we need to program whether or not these answers are right or wrong. Okay, and to do this, once you click on the button, you'll see that if you scroll down, here's an on-click option. And this on-click option is basically telling Unity what to do with this button once it's clicked. Now, answer 1 is incorrect. So we want answer 1 to disappear after it's clicked. So we'll drag answer button 1 into this icon over here, and then we can select a function. So we want this game object to disappear. So game object set active. You'll remember this is the same as we used in code, and then make sure that this is not ticked, then it disappears. Similarly, with answer 2, we also want that to disappear. So answer 2, game object, set bool, make sure it's not checked. Answer 3 is the correct answer, so we'll get back to this one. And answer 4 is also incorrect. So answer 4, select the button, game object, set bool, disappear. Okay, so that then makes our answers disappear. But what we also can do is we can select these 3 buttons and we can add another function to this on-click, which is in our scores manager. So we can say scores manager and then select the function. It's within scores manager, the script, and we want to decrease our score for each incorrect answer by 50 points. So now each time the student gets something wrong, they lose points as well. Okay. Now for the correct answer, what we want to do here is we want to first and foremost reward the student. So we'll add our scores manager, say scores manager increase score, and we'll award 100 points. So they can get negative if they just click all of the answers. If they think a bit, they'll get at least 100 points. So that's always a good thing. So we've got that. And then what we want to do is if they get the correct answer, we want this canvas to disappear. Okay, so let's test out just this canvas section. So the game is going on in the background. We need to sort that out. But yeah, what is the main product of photosynthesis? If we choose an incorrect question answer, we one of the answers goes away and we lose marks. If we select the right answer, we gain marks and the canvas goes away. So we can play again. Now the challenge is we need to, well, not the challenge, we can just switch off this canvas for now because we don't need it. But we need to pause our game if we get one of these upgrades. So let's go back to our script, and then in our Rocket controller, we'll need to check where we get our bonus. We need to switch our time off. So let's do that by saying time dot scale time scale, and we make it 0, and then that makes time stand still completely. But what we also need to do is we need to find we need to manage our questions, because one question is quite easy, but what happens if we've got multiple questions? So we need to create another game object in Unity, And we'll do this as our question manager. So our question manager, again an empty object, we'll add some things to it. We'll create a question manager script, create an edit. And this question manager script is now going to help us navigate through our questions. So each time a student gets a reward, we'll need to ask them a question before they actually get their reward. Okay, so what we need to do is we need to have a reference to our questions. And these questions are held in canvases. So if we want to have multiple canvases, we can say public canvas, have these square brackets, and then say questions. So these square brackets indicates to Unity and that there's multiple canvases that's coming. We don't know how many, but we'll put it into the editor for you. So we want to add questions, and we don't know yet how many questions, but we'll add them as we go along. Then we want to know how many questions have we answered. So this will be a public int, and we'll say questions answered. We can set this to 0, because at the start of the game there's absolutely no questions that was answered. Okay. So we want two functions in this. Let's remove the start and update for now. We want to ask a question. So we'll say public void ask question. And this is going to be our function. So it's public. Anyone can call it, or any script can call it. We don't return anything, and we just give it the name of ask a question. Now, as soon as we ask a question, we want to make doubly sure that time is set to 0. We don't want the game to continue in the background and our players losing out. Now we want to ask a question, so we'll activate our questions, and we'll use that square brackets again, and we'll use questions answered, because that is going to be our counter for this particular endeavor. So questions answered. Okay, and then so this is the canvas. We're selecting a specific canvas, and now we want to activate it. So it's just game object set active, and it's not false. We want to set it to true. And then we also want to know whether or not the question has been answered. So public void question answered. So has the question been answered? As soon as it's been answered, we want time to go back to normal. So time will go back to 1. We know that the question has been increased, so we add 1. This is the short way of saying add 1 is ++. And we want to deactivate our question. Okay, now there's this one issue here. We increase the question answered, and then we deactivate it, and that shouldn't happen. We should first deactivate and then increase. So this is our counter. At the beginning it's 0, so we begin with the first iteration. Remember that in arrays such as these, we always start from 0. Okay, so that then is what we need to do. Okay, so now we need to ask this question manager to ask a question and to answer the question. So in our Unity, once we've on the right answer, we can say add another function. It's on question manager. It's within the question manager script, and we can say question is answered. So when they hit the right answer, the question is answered, and what happens then? As soon as the question is answered, time goes back to normal. We deactivate that canvas, and then we increase the counter for this. But we also need to have a reference to this ask question, and that will lie once we get a reward. And our rewards are set up to be detected on our Rocket controller. So here, if collision game object tag equals upgrade, then we get our reward. So we'll add so we'll add this question manager function here as well. But first we need a reference to the question manager. So again, we'll do public game object question manager. So question manager equals find object of type question manager. Okay, we've got question manager. Here we go. So this needs to be question manager. So it finds the question manager for us, and then in our game tag where we find upgrade in our collision, we'll say question manager, and we need to ask it to ask question, and that will then ask the question. So we can probably delete this time.timescale 0 because we've added it into our question manager. And let's check out if this works. So we hit play. And we see index was outside of bounds. Why did that happen? Because again, we forgot to add our questions. So there was nothing in this array. So let's go to question manager. And here you can add how many questions you have. So we've got one question. Click on the plus button. And then we add that question in here. Okay, the game has stopped. Nothing is happening here in the back. And we get our question, what is the main product of photosynthesis? So let's say carbon dioxide, there we lose some of our score. Let's say hydrogen, we lose more of our score. Let's say oxygen, and the game continues. And we've got our upgraded weaponry. So we are set, and there we destroyed one of our rewards. Oh no. So we've got one question. To generate more, all you need to do is click on your question and Control D, and then you've got more questions coming through. Now, each one of these questions will have exactly the same answer, so it will always be answer free. And that might be counterproductive if you do it like that. So what we could do is you can simply Let's activate this canvas so that you can see. So what you could do is just switch over and randomize the occurrence here. As long as the right answer is associated with button 3, here, it doesn't matter the order that it's here. As long as your answer, the correct answer, is on button 3, then everything will work every time. So now all you need to do is you just need to go and do your house cleaning. So this will be question canvas 2. And we'll change our question and our answers accordingly. So our next question, the process of photosynthesis primarily takes place in which part of the plant? And we'll just make sure. So answer button 3 is always going to be the correct answer, so we'll make that leaves. And then the others you can just add whatever you'd like. Flowers. Okay. Now this question is a bit large for our question box. So what we could do is we can say O2 size, and that will then automatically fit it within that particular button. So there we have our second question quickly done. And likewise, you can do all the rest if you'd like. But at this stage, we'll only do 2. We've got question manager. Let's say that we've got 2 questions, and we add our second question in here. And now, if we get our first reward, we get our first question. What's the main product of photosynthesis? Oxygen. We've gotten our upgrade. We are very vigilant not to lose that upgrade. Shucks. There we go. Process of photosynthesis primarily takes place in which part of the plant? That's our second question, with the answer on a different space. So we can say leaves. There we go. Now, one thing that will happen is that if you get to a third question, it will say index was out of bounds again. That's because we only have 2 questions, and now our questions answered got to 3. So in that case, what we need to do is on our question manager, as soon as our number of questions answered gets to the number of questions that there is, then the player has won the game. So what we need to do is code that now. And we do that by saying that this is going to be in an update. So we want to check for this every single frame. We want to see if questions answered equals questions dot length minus 1. So because we start from 0, and this the total length of the questions is going to be 2. So we want to have it questions. If questions answered is 1, then it will be actually 2. So we need to take that into account. So this is questions answered. So if questions answered equals question length minus 1, what should happen then? And we've got an error here. Cannot. Okay, if we need a double equal sign. So the double equal sign means that this is true. So if this is true, then what should it do? If we only have one equal sign, then it sets question length to questions answered equal to this. So we don't want that. That's why we use double equal sign. So if questions answered equals questions length, then the player has won the game. So we'll again say that time scale is going to be 0. Now we need to activate a winning canvas. So we've stopped time. We need to have a public canvas winner. We'll say winner.setActive game object.setActive true. Okay. Now we've set this canvas true, but we haven't created it yet. So let's create a winning canvas. Right click, UI, and canvas. This is going to be winner canvas. Our winner canvas will have, let's just put a whole panel on. So we'll say panel. We'll make this panel nice green with no alpha. Oh sure, it's going to hurt your eyes. And then we'll do user interface with text saying congratulations. This text we need to stretch center, and we can duplicate this saying you have won. It's down, and there we have our winner canvas, but we also need to add a button should they want to play again. So let's add a button to this UI button. We'll take this button up. Let's make it 400 by 400. Oh no, that's way too big. 100 by 100. Okay, and this button we'll say replay. So we've got replay, but this button doesn't look quite nice. So what we could do is we can upgrade this button, how it looks, by going into our sprites folder and selecting this restart image and dragging it to the button image. And there we have a nice replay. This text we can make white. And there we have our winning screen. Now this button won't work yet, so because we haven't told it to do anything. So what we need to do is create some way of managing the stage and the scene. So we'll say create an empty object. We'll name this scene manage. So we name it scene manager. And as always, we add a script to it if we needed to do something. Scene manager. Scene manager. No, we'll name it something else. Because scene manager is actually a term in Unity, and this manager of scenes. Otherwise, we'll get an error. Manager of scenes. We'll go manager of scenes, edit. And here what we'll need to do is we'll first need to add a reference here using Unity engine.scene management. You can delete the start and update methods, and what we want to do is we want to load this scene again, so void load scene. And first we need to set our time back to time scale 1 so that time functions normally, and then scene manager load scene. So this is going to load a scene, and we want to get the active scene that we are busy with now. Scene manager active scene get active scene name. That's all that you need for this manager of scenes. So upon this button pressed, what we want to do is the scene manager and the manager of scenes needs to load scene. Okay, and we can switch off this canvas, and on our question manager we just need this winner canvas added here, and that should sort out our problem of having too many questions or too many rewards. So let's see if I can play. Okay, what's the main product? Oxygen. Now it says congratulations, you win. Restarting the scene. There seems to be some issues. So I found my mistake, and it was in my explanation of the -1 on our question manager. So here we said that if question answered equals questions dot length -1, and it should just be questions dot length. I forgot that Unity recently did an update where they made this redundant, so that's sorted out now. So if we go into our game and we hit play, we'll see that we get our first question. And once we get our second question and we've gotten the right answer, we get congratulations screen. Now if we hit replay, we see that nothing happens, and we can rectify that by going into our game, into our Rocket Controller script, and here at start, just resetting time. So this is the first script that we started with. It's the first script that ran, so we can add time to timescale at any start point for this particular script, for this game. But in the Rocket it works best, and as soon as we've done that, it should work. So let's see, when do we get our next reward? Congratulations, replay, and the game starts immediately again. Okay, so we've got a winner canvas, but similarly we also need a loser canvas. So we can just make a copy of the winner canvas, rename it to retry canvas, just to make it a little bit more on the positive side. Mission failed. Please try looks. Mission failed, please try again. Let's make this background rather orange. Good work. So that the student needs to try this again. So that's our retry canvas. We can switch this off. And the button will automatically work because it's been set up. So it's just a restart of the scene. But we need to call this retry canvas somewhere, and that is going to be called when our rocket gets exploded. So on the rocket controller, we can go into the update on collision enter, where we've got no, it was on update. What's this? Oh, we haven't coded it yet. No, here we go, on the late update. If shields are less than 0, then we want that kaboom, and then we want that that canvas to pop up as well. So we can say game object. No, we can just say retry canvas set active to true. And we need a reference to that retry canvas public object. Okay, so we've got the game object set up. Now on our rocket, we need to find the retry canvas, and it should then work. So let's check this out. Okay, so our goal is to explode. There we go, replay mission. Once we hit it, we can retry our mission and get going again. So all the functionality is in our game, and it's rather playable. We have a learning experience that we can easily enhance and upgrade. We can add more questions relatively easily. We've got rewards, and you can upgrade this experience as you see fit. So the more questions you ask, the more challenges you involve, the more upgrades you get, the better the game experience is going to be. What we don't have is sound, and that's quite a pity, because sound can really make or break a game. So first and foremost, let's create our folder. Right-click, create folder, and this is going to be sounds. In our sounds, we'll create 2 folders. The first is going to be music, and the second one is going to be sound effects, which we can somewhere make SFX. Okay, now in the folder that I shared with you, you'll find a few different sound clips. You can take a listen to them. The only music that I've included is called Stranger Things, so that goes into the music folder, whilst all the rest goes into the sound effects folder. Now for sound, we need to add some sound or audio sources. So what we'll do is we'll create an empty object that we'll call music controller. add an audio source, and then on this audio source you'll see there's an audio clip. Now this is just going to be music, so click on Music Controller and drag Stranger Things in your music folder here. Now if you start your game, you'll have music that plays in the background. Now you can play around with the different functions here. You can switch the volume a bit up or down if you'd like. What is important is to loop the music, especially if you've got a longer game, then you need to loop the music. So that's music sorted quite easily. The next thing we need to create is another game object. This is going to be our sound effects controller. And for this one, we also need a audio source, and we'll add a script called sound controller. Edit the script. Okay. There's a few different places that we would like to play sound, at least for our students to be actively engaged. So let's think about this. We need to play sounds, and these would be then audio clips. Audio clip when something explodes, when they receive a bonus, when it's player game over, and when they shoot. We can also have an array of audio clips with positive reinforcing audio. Let's say supportive audio. And then we need to have a link to our audio source. So we'll keep that private and we'll just call that audio source. So in our start method, we'll do audio source equals get component audio source. AI is amazing. And then we'll need to generate specific functions for each sound. So we'll do public void play shoot sound. And the way we place a sound is first we need to line up what audio clip is. So like DJ, audio source, and we say clip. So what clip are we going to play? And this is the shoot sound, so we'll do shoot. And then we say audio source.play. And that's all you need to play a specific sound. So we've got the play shoot sound. Let's copy that. Copy that 4 times. So we've got play game over sound, which will then change to play game over. We've got play bonus sound, should be bonus. You know what, rather let's make this a reward, because we had it as reward throughout. Let's not make ourselves the macaw. And then we've got explode explode here. Okay, then we need one last function, a supportive sound. This would be audio source clip equals supportive, open brackets, and then this is going to be random range 0 to supportive length, and audio source play. So it plays a random sound on that one. Now let's to Unity Sound Effects Controller. We need to link up all these sounds. So SFX. So amazing is one of our supportive sounds. We've got incredible, which is also a supportive sound. Outstanding, supportive. We've got shoot. We've got a hyperspace explosion. That's when it's game over for us. We've got a bad explosion. That is just a normal explosion that happens. And then we've got a game level. That's going to be our reward sound. But now we need to link this up. So we need to go back into our scripts, go to Rocket Controller, because that's where we have some of our things happening. Private sound controller, and we find the sound controller. Okay, then we just need to link it up where we need the right sounds. So here's where we'll have our massive explosion. So this is going to be sound controller. What did we call it? Sound controller play game over. What did we call it? Let's just go back. Play game over. It's with a capital. So that's why. Play game over sound. Okay, then here's an explosion for our small little guys. This is going to be sound controller. Play explode sound. When we get our upgrade or bonus, we'll say sound controller play bonus sound. Let's make it upgrade. Reward. That's right, we had it as upgrade. Upgrade. And this needs to be upgrade as well. Upgrade sound. And what are we missing? We're missing a semicolon there. So we've got explode, we've got upgrade, we've got, did we get shoot? Laser beams. Laser spawner. Spawn laser. Where does spawn laser happen? It is when we press spacebar. So we need to have it here. Sound controller. Play shoot sound. I think that is everything that we needed to set up in terms of sound. So let's just check. Yeah, upgrade sound has gone because we got a new name for it. So let's check this out. Okay, so it seems that everything is working except our exploding sound. Let's go back and just double check what is happening, what I did wrong now. Play explode sound. Play explode sound. It could be that our music is a bit too loud and that our sound effects is not loud enough. So let's switch our music volume a little bit down. And that also didn't sort it out. Let's just check. There's definitely sound on that one. And our sound effects controller. I see now. So we've entered our sound controller playing sound when we collide with an enemy, but not when we shoot an enemy. So we need to add that to the shoot side as well, and that is within our laser beam. So we need to have a private sound controller here, and then we need to add that, and then we can just say sound controller dot play explode sound. That is what we are missing. And now just like that, we've got a fully fledged game, and it is working. We can ask questions, we can make it more interactive, we've got sound, and there's so many free resources available for you to generate games. And I hope that you enjoyed this experience. We'll have a final discussion on today, and I would really like to welcome your feedback. Thank you very much for joining in, and we'll chat soon. The final step in your creation process is to save a final version of your work, and then do a few steps before you can compile your work. So go into build settings, file build settings, which is a tab that looks like this. And here you can find the player settings. So first, before we go to player settings, delete the sample scene and add open scenes, and then say player settings. And here you can enter your company name under player settings. So this will be Metaverse Research Unit. I named my game Road to Mars. Under icon, you can say override for Windows, Mac and Linux, and select the icon. So let's use our rocket, for instance. Then under resolution, what we want to do is we want this to be a windowed game, 1920 by 1980, that's perfect. Splash image, if you'd like, you can add your logo, any image that you want to splash. So that shows at the start. And under other settings, you just want to correct this, so it's going to be com.metaverse research unit .road to Mars. Okay, those are the main settings. Like I said, Unity is very powerful. You can change multitudes of these settings and get experiences like truly AAA style games, but ours is almost there. And yeah, as soon as you've done that, then you can click on Build, right click and say New Folder. This is going to be Installation. Select the installation folder and then just wait for the build to complete. And once the build is complete, you'll have a file with all the different things that you need in it. And if you double click on Road to Mars, which is what we called our game, you'll say, here we go, our game. With that, I say thank you to you for joining me in creating this game, and I look forward to working with you in future. If you've got any questions, please reach out to me at hermanm@uj.ac.za, or via the library you can contact me. Thank you so much.